So it's minus 2a squared, I can write it, is minus 3 pi over 2r squared plus 2a squared, okay? Now, this is dc1 of t. In the same way, from the integral b to a, we found the same calculation. Then the final result is 2 times. So we have the same calculation. The integral of e dl2 from b to a, using the same method, we found the same result, minus 3 pi over 2 r squared plus 2a squared. So E over dl closed surface is 2 times this one, so it's minus 3 pi r squared plus 4 a squared. This is the first one. This is the end of the first part. Second method, we can use the Stokes theorem, where E dl equals to the curl of E ds. Okay, so the curl of E equals to, in Cartesian coordinate, x, y, z, d over dx, d over dy, d over dz, of ex is minus y, ex is minus y, okay, minus y, so ey is x, and ez is z. So d of, in the direction of x, d over dy of z is 0, d over dz of x is 0. So in the direction of x, we have 0x, okay, plus in the direction of y, so d of dz of y is 0, d of dx of z is 0, so 0 in the direction of y. So we have just in z direction d over dx of x, d dx of x is 1, plus minus d dy of minus y, so it's minus 1. So minus 1 is plus 1, it's 2z. Okay, this is the curl of E. So the curl of E is, it's not dot, it's, yeah, across, is 2z. What about ds? Our ds, we can see, we can draw it again. For example, I can do it like this. We have a like this. This is, we can consider that this one is like the surface S1, okay, and the second surface, like the surface of the part of the disk, is S2. This is a part of disk, okay, and this one is 2 triangle, okay. Now our surface, if we try to use our hand from A to B, so we have x and y. So this is the direction of our path. Okay. So using this direction, z will be on the other direction. Is minus z direction. Okay. This one is z and minus z on the other direction. Okay. So it is. It's of course ds vector with vector is minus the direction of z, okay, by minus like this, minus the direction of z. Z is like this, but our direction is in the other direction, opposite direction than z, okay. So it is minus in the direction of z. What are the variables? Dx, dy, okay? Dx times dy minus dx dy in the direction of z. Now, if we try to find the curl of E ds, the curl of E ds is double integral of minus 2 dx dy. Z dot z is, okay, minus 2 dx dy. So we are just looking for the surface of this part and the surface of the second part. So in this case we have 2 times this surface, okay, 2 times this one plus the second part, okay. So we can find for this one then the value times 2, okay. We can separate, we said S1 plus S2, so ds is ds1 or the surface S1 plus S2. In this case we are just looking for the surfaces, okay. So it is minus 2 2 times this, okay, times 2 times this, double integral of dx dy, but dx dy times, okay. So I call this one is S1 and the second one is S2, okay. Now S1, we can use the integral dx dy, of course, y from 0 to x, etc. So to find this function, etc. But we can directly, we know that we are looking for the surface, and we know that the surface of the triangle is a dot a over 2, because they are perpendicular, so a square over 2 times, so it's a square. Directly we have a square plus, what about the surface of this disk? We can use, if you remember, we did it in the previous session, etc. For example, this is dl, did r dl, so did r, the integral of did r dl, dl is r did phi, so r did r, did r, the integral is r square over 2. If you remember, we did all of this, and times the angle phi, because it's rd phi, okay, etc. Then in this case we know directly the surface of the disk is the angle dot r square, or we can do it like this, okay. The angle over 2 r square, so it's, in this case we have 3 pi over 4 2 times, so it's 3 pi over 2, okay, 3 pi over 2 again, so it's 3 pi over 4 over 2 because of this, okay, r square. So this is the surfaces. We know that we have 2 circles, not one, so E over this surface and E over the second surface, so it's 2 times this surface times minus 2 of course minus of the direction and 2 of the curl of E, okay. So it's minus 4a square plus, with minus 3 pi r square, okay, 4 with 4. Is it the same result as the previous one? We have to check. Where is, yeah, it's the same, okay, the same result, okay. What is this plus 4 and we have minus 4? Why? We can look. Yeah, just here when I write it, it's minus 2a, okay. We have this minus, it's minus, I didn't write it well, minus 2a, this minus 2a, so it's EDL 2 times, so it's minus, it's minus 2, all of this, so it's minus, okay. So we have the same result, okay. So this is a minus, this is a result, this minus. Thank you for watching, and good luck for your control.